So you have this old legacy application on your screen, it needs some fixes, new features, and the problem is all this has to be implemented in a WCF service. Well, don't panic, I'm here to help. WCF services are still quite often used by bigger corporations, but also small teams, because these companies use older software which was built with these kinds of services. Now, people with deep knowledge of WCF services are quite rare, but that's actually your chance. By the end of this REST WCF Services for Web Applications course, you will be able to build WCF services from the ground up completely by yourself. You will be able to fix bugs and change existing implementations, maintain these like a pro, and then cheer up like these kids. Yay! So let's have a look what you're going to learn in this course. You will be able to build Ajax-enabled RESTful WCF services with Visual Studio. We will cover the web config for the web service, and I will explain every attribute in this configurations file. We will implement CRUD operations with custom classes and lists. The common HTTP methods, meaning get, post, put, and delete, will be covered. We will do more than just CRUD, we will also do some filtering, custom searches, sorting, and so on. And in the end, we will also talk about debugging and sending status codes back to the client. Now, to realize all this, we will build a little web application with JavaScript and HTML. Now, most parts of the client will already be available for download, so you're not bothered by this stuff and you can totally focus on the C# code and your WCF service. But still, you will implement the actual Ajax calls to the web service by yourself in JavaScript. I'm Patrick and I will be your instructor for this course. I'm a web developer for over a decade now, and I worked for bigger corporations with thousands of employees, but also small teams with maybe 5 people, and also completely by myself as a contractor. To this date, I was able to publish 3 courses on software development with a total number of over 20,000 unique students. You can be one of them. Sounds good? I'm looking forward to see you in the course. Hi there, welcome and thank you very much for joining the REST WCF Service for Web Applications course. WCF services are still often used in many corporations, so that it's extremely helpful for your career to have the skills that you will learn in this course. The only thing you need is Visual Studio, a browser with developer tools such as Google Chrome, and of course the desire to learn new skills. During the next sections, we will build the service part with C# in Visual Studio. To call all your service methods, we will use jQuery so that you know how your implementations can be called from a web application. The HTML and CSS part is already done for you. I prepared a minimalistic web page that will display all the results from the web service and provide all the buttons and links you need to execute the calls to the service. Additionally to that, we will also use the developer tools of Google Chrome. There you will also see all the results of your calls, and you will be in the right environment to see all the header and network information too. Now, with this setup, we will build a small superhero database. The WCF service will create, read, update and delete superheroes, and we will also build additional methods to filter and order these heroes and also let them fight to find the strongest one. But first, let's already create our RESTful WCF service in a very fast way. Alright, I would say let's start. Adding a WCF service to your web application can actually be done real quick. Let's jump right in. In Visual Studio, we built a new empty web application. We click on File, New Project, and then from the templates we choose Visual C#, Web, and then ASP.NET Web Application. Of course, you can then give it a reasonable name, or you just leave it at the name that is suggested by Visual Studio, and then we click OK. After that, we choose an empty web application. So the first template you see here, and we leave anything else unchecked. We don't need any web forms, no MVC, and also no web API or authentication. Again, then we click OK. Alright, after your new web application has finished loading, let's add a new folder in the Solution Explorer under our new project. So we right click the project, add new folder, and we call this folder service because that's where our WCF service will be placed. And after that, we right click this folder and add already the WCF service with add new item. Now for this Jumpstart lecture, it's important to add the WCF service right here, which is already AJAX enabled. This means that our service will already be a RESTful WCF service. We'll talk about the details in a later lecture. For now, just click Add. And now you'll notice that some things have changed in the Solution Explorer. First, Visual Studio has added some references for us. Here's the system runtime serialization reference, and this namespace contains classes that can be used for serializing and deserializing objects. Then system service model contains the types necessary to actually build WCF service and also client applications. And system service model web provides classes related to using the service model on the web. Then the service files have been generated for us. The service1 SVC file and its code behind file, where we will put all the C# code for the web service. We'll have a look at the C# code in a second. When you right click the service file here and click view markup, you see the markup. At this state, it's not very interesting for us, but if you change the namespace of your service, for example, Visual Studio might not change this markup here for you. So keep that in mind. If any errors occur, there might be a problem with your markup file. Okay, and last not least, the Web.config file. This one was already there, but the content has changed so that the service can be consumed from the web via AJAX. I will explain the Web.config changes as well as the attributes in the actual C# code in the next lecture. For now, let's go to our service class and have a look at the method doWork. So this is our service class, and here's the method doWork. At this state, it returns nothing. Void right here, and we want to change that so that we can see an actual result in a few seconds. The method should return a string like that, and of course we want to return a text like that. Now this is an empty text. We could say something like hello world, or maybe something like hello, I'm Patrick. Of course, feel free to change the name right here. Now the next thing to do would be already to call this method through the browser. Before we can do that, one little thing is still missing. We have to add the attribute WebGet, which is also explained right here in the comment above. So what we have to do is simply add WebGet, and that's already it. Okay, now we can build the project. And then we right click the service file in the Solution Explorer and say View in Browser. Now, as you can see, the service is already working. The only thing we have to do now is adding something here in the address bar, and that is the name of the method, which would be doWork. And you see already your service is working. That's it. Again, in the next lecture, we'll have a look at the used attributes in our C# code, and we'll have a deeper look at the Web.config file. In particular, we want to get rid of the strange result here, the strange format, because in our application, we want the plain JSON objects. All right, first, let's have a look at the C# code again. We see some attributes here that are crucial for our web service. The first one is service contract. This one indicates that an interface or a class defines a service contract in a Windows Communication Foundation, or short WCF, application. This in essence simply means that we have a class here that has operations, hence the operation contract attribute later on, that can be accessed from the web or any other client application accessing this web service. Next would be the ASP.NET compatibility requirements with the requirements mode set to allowed. This simply means that this WCF service runs in the ASP.NET compatibility mode, which in turn means that the service is able to use certain ASP.NET features such as file or URL authorization. That's all we need to know so far. Then already we have the operation contract here. As already mentioned, the operation contract goes hand in hand with the service contract attribute. This means that the following method is an operation that is part of the corresponding service contract class or interface. And finally, the WebGet attribute. This one is crucial to use the Windows Communication Foundation REST programming model. So this attribute enables us to actually use a REST call to access the method from our service. Additionally to that, WebGet indicates that we have to use an HTTP GET request to access this method. Also, WebGet comes with additional arguments like the response format or the URI template, but this is something for a later lecture. For now, these are the attributes necessary for this jumpstart. Next, we'll have a look at the web.config. In the web.config, we have a new section called System Service Model. This one right here, similar to the edit reference. This section contains all the WCF service configuration elements. So the service model section starts with the behaviors collection, which in our case contains one endpoint behavior. Now we hear endpoint a lot when it comes to web services, but what is that actually? An endpoint, put simply, is just the end of a communication channel. In our case, any URL of the web service you are going to call in this course is an endpoint. You'll get to call lots of URLs later on. So after the behaviors collection follows an endpoint behaviors collection, and after that finally we can find the behavior, this one, with its automatically assigned name. Fun fact here is, with .NET 4 we actually don't need a name for the endpoint behavior. But if you remove it, make sure to also remove the behavior configuration in the service endpoint configuration down here. Well, now it's getting interesting. The setting for our behavior currently is enable web script. Set by default, this setting makes it possible to consume the service from ASP.NET Ajax web pages. This is totally fine, and as you have seen, it already works. Microsoft wrapped the results for security reasons, and you can absolutely work with these results. You just have to access the properties of the service responses a bit differently. But for this course, we want the plain JSON objects. So to get rid of this strange format, we have to change the setting and use Web HTTP instead. Now let's build the project and see the results. So just reload the page. And what's that? We suddenly get an XML result. So JSON is not the default response format anymore, but we can easily change that. Maybe you remember that we can change the response format with the WebGet attribute in our code. Let's do that now. We switch to our service implementation. We go to WebGet, and in brackets, we add response format equals web message format JSON. And then of course we close the brackets. Okay, now let's build our project again. We reload the page. Perfect. This is exactly what we need. Back to the web config. Now, setting the ASP.NET Compatibility Enabled attribute in the service hosting environment to true simply means that the ASP.NET HTTP pipeline is used for the communication with the server, and the communication over non-HTTP protocols is prohibited. The multiple site binding attribute specifies that binding multiple sites via Internet Information Services, IIS, is enabled. So nothing fancy here, we can leave it at that. Last but not least is the services section, which defines the service contract, behavior, and endpoints for this particular service. The name typically consists of the namespace and the class name of the service. Now the endpoint element and its properties finally is used to expose the service. The address is empty by default so that the base address is used, which we have already seen in the browser. Of course, if you feel like it, you can change that. But for the beginning, we just leave it empty. The behavior configuration contains the name of the behavior to be used in this endpoint. As you can see, we use the behavior we have configured above in this case. This one right here. Alright, of course we could go deeper, but in essence, this is actually everything you need to know. Alright, to make things a lot easier for you and to get right to the code, I prepared a Visual Studio solution. This solution already contains the class Superhero, as you can see here, and a prepared list of several heroes right here. Additionally to that, all the HTML stuff is already covered so that we can fully focus on the C# code and the implementations necessary for the service, and also a bit JavaScript to call the WCF service from the browser. So please download the solution here from the resources and open it. When the solution is open, you can come back and we will go through every detail together. Alright, let's have a look at the code that's already there for you. So as you can see here in the Solution Explorer, we already have our WCF service. It's added exactly in the same way as you've seen in the Jumpstart lecture before. For testing purposes, it already implements a doWork method that simply returns a string. In this case, this is the Superhero database service. Let's test that now. Simply build the solution. Then right-click the index.html and choose View in Browser. Okay, now we can access the method via the address bar. Don't get confused by the things you see on the page right now. We will come to that in a minute. For now, we remove the index.html first, and then we go to the service folder, and then you can already see it there. We access the superhero service.svc file, and finally call the doWork method and hit return. There it is. This is the Superhero database service. Perfect. Everything works just fine. Now back to Visual Studio. Let's have a look at the Web.config. As you have already seen in the result, the important web HTTP behavior is already set. You can see it right here. So the Web.config looks very similar to the one from the Jumpstart lecture, only the names have changed. So we can already move on, and next would be the Superhero class, this one. This is in essence the data we will send to the client. You already know how to send a simple data type like a string, for instance. The next step is the custom class right here. Every property you see here, like the name, birthplace, strength, and so on, will also be available in the browser as a JSON object. Alright, next would be the data.cs file. And this is just an example for a list of heroes we can and will send to the client. All these heroes can be updated or deleted, for example, and they will fight against each other later on. Okay, so far the backend stuff. Now let's have a look at the front end. First would be the index.html. Here you can see the JavaScript files and the CSS we need to display all the results. Additionally to that, here are already all the divs and the table for all the superhero data. The diffs will be shown and hidden depending on what we actually want to see. We will talk about the details in the corresponding lectures. The matching CSS file can be found right here. Not very much to see here, just some adjustments like the font and the looks of the table so that we don't have the default setting for the HTML page. Okay, now let's have a look at the JavaScript files. The service.js. This one is currently empty. Here we will write all the code necessary to call our WCF service. So it's getting exciting here. And at last, the app.js. Here you can see code that will handle the responses from our web service and display the results properly in the browser. Again, we will have a look at the details in the corresponding lectures. Okay, then there's also the jQuery code. jQuery is just a library that makes our lives easier when using JavaScript. It provides methods to access elements in the HTML, the so-called DOM elements, faster, for instance, and we can also create and update these elements more convenient. Great, that's it. I hope you are prepared. Now get ready for the next section where we will build all the CRUD operations and HTTP calls in our WCF service. Welcome to the CRUD implementations section. If you skipped the other lectures, make sure to at least take a look at the preparations lecture where we download and go over the prepared Visual Studio solution, which is the foundation for all our future implementations. And if you're still not convinced, just download the solution from the resources. Now in the upcoming lectures, we will implement all the CRUD operations for our WCF service. But what does CRUD actually mean, you might ask? Well, CRUD is an acronym for Create, Read, Update and Delete. This means that we will implement all the basic features for our web service, and in essence, these features have to be implemented almost every time you build a web service with a custom class. Almost every time you want to create a new object of that kind, you might want to be able to read it in the browser, update any information of the object, and in the end also delete an object again. Of course, there are variations of these operations. A deletion might not really be a deletion after all. You might want to keep this particular object in the database and just set a flag that this object cannot be accessed through a standard read operation anymore. That's a so-called soft delete. And in essence, this would rather be an update because actually you're just changing a property of the object instead of really removing it. Regarding reading objects, you can decide if you want to read only one particular object or a list of objects with certain properties, for instance. So all these CRUD operations will be covered in this section. We will build the backend part, of course, and also have a look at how you can call the implemented web service methods in the front end. But first, let's have a look at the HTTP request methods in the next lecture, because all these CRUD operations have an HTTP counterpart. I promise, this is the last theory lecture. The Hypertext Transfer Protocol, or in short HTTP, defines, as the MDN web docs put it, a set of request methods to indicate the desired action to be performed for a given resource. To this date, we can find 9 request methods in the documentations. The most common ones are get, post, put, and delete. These are the ones that are covered in this course because you almost always can do everything that needs to be done with only these 4. Let's go over them shortly. The get method requests a representation of the specified resource. If you're using this request, you should only receive data from the web service and not send data to it. Of course, you might want to send certain characteristics to the service like an ID or a string, and the backend then grabs the proper object from the database, but you won't send any objects to the service. This in turn would be done with a post request. The post method is used to submit an entity to the specified resource, often causing a change in state or side effects on the server. Now this means that you might want to add a complete new superhero entry to the database. For example, post means, to put it simply, add or create a new object and do whatever you want to do with that object in the backend. Usually this new object will be saved in a database. The put method replaces all current representations of the target resource with the request payload. So this is in essence an update of the complete object. If you want to change a property of a superhero, let's say just the name for example, you would send the whole object to the service and it would overwrite the complete entry in the database. Of course, there can be variations of that process, but the standard way is exactly like that. Send an object to the service that already exists and update every property of this object. Okay, and finally, the delete request. You know it already, the delete method deletes the specified resource. So you send an ID to the service usually looks up the corresponding entry in the database and erases it. If you rather want to do a soft delete, meaning just set a flag so that this entry will not be shown on the client, it's actually an update where you would then use the put request method. Okay, but to make one thing clear, nothing works automatically. You have to write all the service methods by yourself and define which HTTP request method has to be used by the client. You could in fact write a service method that uses get, but then simply delete an object with a given ID. It's all up to you. Now the CRUD operations from the last lecture and the HTTP request methods match perfectly together. Maybe you already know how they match. To create an object, you would use post. Reading an object is done with a get call, updating with put, and deleting, well, with delete of course. Okay, now that's it for the theory. Congratulations, you made it. Now let's write some code. Okay, let's remove the do work method here now, because we want to start completely from scratch. In this lecture, we want to receive the whole list of our superheroes and read it in the browser. The method itself is quite simple. We need a list of superheroes. And then we call this method getAllHeroes. And of course we can resolve this issue here by using system collections generic for the list. Okay, and then what we want to return is simply the whole list of our superheroes. So as I said, the method is quite simple and that's already it. Now the thing that is missing here, of course, are the attributes. Now similar to the do work method from before, we have to tell the service that this is an operation contract. And to make sure that this is a get method and that we will get a JSON object from the service, we add the web.get attribute with the response format, which would be web message format, and then JSON. Okay, now you could also add the web.get attribute directly after the operation contract, like that, but this is totally up to you. Okay, that's it already. Let's save the progress and then we switch to the client side. Now we open the service.js file and also start writing a new method, which we also call getAllHeroes. Now it's getting interesting. How do we call this method from our web application? We will use jQuery and Ajax to make an asynchronous call to the web service. Again, jQuery is a powerful JavaScript library which makes many JavaScript functionality easier, especially when it comes to browser compatibility. So for example, you might write code for Chrome which doesn't work in Internet Explorer. If you use jQuery, it handles these issues for you. Additionally to that, you can access DOM elements with jQuery faster than with plain JavaScript. And AJAX is just a set of web development techniques that allows us to do the upcoming calls to our web service. It stands for asynchronous, JavaScript, and XML. And asynchronous simply means that your web application won't stop working while it's waiting for the response of the web service. So every button, for example, still reacts to user input. Alright, but enough of that, let's write the call now. We start with the $sign. This indicates that we want to use a function of jQuery now, followed by the AJAX method. Now this method wants an object with some arguments. The first one is the URL. In our case, it's service, then superhero service SVC, and then our method getAllHeroes. So we start with service, then superhero service SVC, and then our method getAllHeroes from the web service. Okay, then the next would be the type. That's the HTTP method, so here we enter get. Now the data type, this one would be JSON. And then we have to tell what actually should happen with the result of the service, meaning in the success case. Here we add another function that receives the result from the service, and with this result we set our global heroes list and also call the method drawHeroTable with the given result, like that. Okay, these last two steps are possible because the heroes list and the drawHeroTable method are already prepared in the app.js file. We can have a look right here. Here's our heroes list, and the drawHeroTable is this one right here. Now the heroes variable is necessary for future implementations, and the drawHeroTable method, well, as you can see here, it creates a bunch of HTML and adds it to the table where all heroes can be found. In a new application, you would have to write the code for these first, of course, or you can always write the result to the console, which would be done like that, for instance. And then you can see the result in the console of the developer tools. Now that's actually what I always do when I implement new features. It's the easiest way to check if everything works just fine. Okay, now let's remove that again. And then there's one last thing we have to do here, which is calling the new getAllHeroes method, of course. So we go back to the app.js and scroll way down to the bottom. There is the document ready function here, and this method is always called when the whole website has finished loading. In this case we want to call the getAllHeroes method, so let's do that. As you can see, this is already prepared. We just uncomment it, and that's already it. We are done here. Now let's save everything and build the whole project. Okay, and now let's see if everything works by hitting the index.html again and view this application in the browser. And as you already can see, here are all the heroes. Perfect. Now let's have a look at what actually happened under the hood in the next lecture. Almost every browser nowadays has so-called developer tools. But what are these and what can you do with them? Well, let's have a look at the developer tools of Google Chrome. So we see our small web application here, and as soon as we reload the page, everything works just fine. To access the developer tools, you can either hit F12 on your keyboard or go to the menu, then More Tools, and then the Developer Tools. There are plenty of information here. For now, the most interesting tabs are Console and Network. In the console, you will see everything you log manually with JavaScript or automatically logged events like errors. Now the Network tab shows us the actual calls to the web service. When we hard reload the page by right-clicking the Reload button, empty cache and hard reload, we see a bunch of information down here. We see all the files the website was downloading and, even more interesting for us, the web service calls. Let's filter them by using the XHR, which stands for XML HTTP request button. Now we only see the web service call. When we click on it, we see even more information. The most interesting information for us at the moment are the request URL right here and the request method, which would be get, and then the status code. It's always a good idea to check if these things are right if any unexpected behavior occurs. Now the status code 200 means that everything has worked just fine. An error would be, for instance, 404, which stands for not found, or 403, which means forbidden. Okay, another helpful tab is the response or the preview of the response. In this case, you can actually see what the web service sent back to the client. You see the list with every single superhero and its properties. This is also very helpful if anything doesn't work as expected or if you need to know what properties you have to access. Now the timing tab is usually used if you have any performance issues. Here you can see how fast your result comes back from the service. In this case, it took 8 milliseconds. Alright, feel free to play around with the developer tools. What I always like to do is really having a look at the preview of the response so I can see if everything is correct and if I got the correct properties. So keep in mind that it's always a good idea to have the developer tools open and have a look at what is going on underneath. Now let's continue with receiving a single hero from the service. Now this is just an example how receiving a single entry from the service can look like. You may have seen that every entry of a superhero has its own unique ID, and we will make use of that ID to get the particular entry. The new method looks quite similar to the one before, so let's copy it for now. We just grab it here, copy and paste. And now we empty the body. What we want to return is just one single superhero and not a list of superheroes. And we call the method getHero. Now it's important to add an argument to the method. In our case, it's the ID as an integer. Alright, for the body we use a one-line link statement. Now we return from the data superheroes list that entry with find, that entry that has the ID of the given ID in that argument above. Okay, and this find statement will do exactly that. It looks into the superheroes list and just looks for the one entry that has the given ID. Okay, that's it already for the backend part. Since we don't actually need an AJAX call on the client side for this small web application, we'll test the call with the address bar of the browser. So let's save and build the project. Okay, and now we can go back to Chrome, simply reload the page, and then we go to the address bar, and as you've already have seen, we enter service, superhero service SVC, and instead of do work, we enter get hero and add an ID of a hero, for example, 0. Hit enter, and there it is. As you can see, the whole entry is returned exactly like the ones from the first call of the last lectures. This can also be seen in the developer tools. We just have to switch the filter again. Here is the call, and here is our response. You can access every property and do whatever you want with it. The crucial part is the added argument in the URL of the call, this ID here, which should be 0 in our case. Now, a typical REST call might not always look like that. It is possible to use something like that. Let's say get hero and then just / and the number or the ID 0 or 1 or whatever. But this has to be configured in the backend, and we do exactly that right now. So we go to the Visual Studio solution, and in the web get attribute, we enter a new property which is called URI templates. Here we can enter any desired name, but I recommend the name of the method, so we say get hero. But now comes the new part. We add the / and then the argument, which would be the ID, in those curly brackets. It has to be the proper name of the argument of the method, otherwise this would not work. Now, one downside of this is that an integer won't work anymore. We have to use a string in this case. So we change that int to a string. And then what we have to do when we change the data type, we also have to cast the string to an integer in the link statement down here. So what we can say is we want an integer and parse the string, which is in this case the ID. All right, now let's build the project again, and then we check if everything still works. So we go back to Chrome and we reload the page. As you can see, the previous call does not work anymore. But if we do it like that, again, we get the same result. Great, that's it for a single hero. We will make use of the URI template in the upcoming lectures. Now it's time to add a new hero to our superhero list. To create or add a superhero, we start with our method addHero. So we create a new method, we say public, and we return the superhero when it's done. We call the method addHero. And the new thing here is now that we need a superhero object as an argument for this method. So we say superhero and also call the argument hero. Okay. The body for now is empty. And what we want to do is we have to manually set the ID of the hero entry so that it stays unique. Because we have a bunch of heroes in our list already, and the IDs are 0, 1, 2, 3, and so on. And to keep the IDs unique, we have to manually change them. And we can do that again with a link statement. But first we say the hero ID equals, and then we want to have the max value of the IDs of all superheroes that are already in the list. And then we say sh for superhero, not short, superhero, and say the superhero ID, and then just increment it by 1. And what we need here, of course, is the link reference. Okay. After that, what we have to do is we have to add this superhero, this new hero, to the superheroes list. And we can just do it by that. And in the end, we return this created hero. Okay, that's our body of the method. Now the attributes, again, of course, we want this to be an operation contract, so we can access this from the client. And now something new is happening. You already know that we need a post request for creating new objects, so web-get doesn't work anymore. This time we add the attribute web-invoke. Let me scroll down a little bit. Okay. Now with web-invoke, we can define the HTTP method we want to use. But first, similar to the web-get attribute, we start with the response format. So we have web-invoke already here, and then we say the response format equals to web message format, and again JSON. And then we set the body style of the messages. That's the body style. And this will be the style of the messages that are sent from and to this service operation. We have 4 options here. As you can see now, we have the web message body style bear, wrapped, wrapped request, and wrapped response. We will use bear in our case, which means that both the request and the response won't be wrapped, so that the result of our service operation is written directly to the body of our response message. It's easier to access the result that way, otherwise it would be wrapped in an additional object. Alright, next would be again the URI template. In our case, it's quite simple. We will use add hero. And finally, the HTTP method. We just use the method property and set it to post. Now we can close the bracket and we are done here. Okay, so far the back end. Now let's switch to the front end. For the client part, we will add an add hero method in the service JS. So we start with a new function, call it add hero. That's it. And again, we need an AJAX call, but first we have to build the object that will be sent to the web service with that AJAX call. This object, for instance, can be called new hero. So let's say var new hero, and this is a new object which needs several properties. Okay, in essence, the same properties that we have already seen in our superhero class in the backend. So first would be the first name, like that. And to get the value of the first name, we will use jQuery to access the text field where the user can enter the first name. Let's have a look at the web application for a second. So we go to Google Chrome, and this was our last state, but we can simply say we go to the index.html, make this a bit smaller. So we see the table with all entries, and here is the link to add a new hero. As you can see, when we click the link, there are some text fields where the user enters all the properties of a new superhero. And we want to access exactly these values with the help of JavaScript or jQuery. So let's go back to the code. And again, we use the $, and then we need the ID of the text field. Now in the index.html, we can find it right here in the input fields. So you can see the div right here where the user can add a new hero and enter all the values. And within these input fields, we have the ID, and in this case, it's add first name. So we simply select it and then copy it. And then we go back to our service.js and we can say, give me it's important to add the hash here, because then we tell jQuery, give me the field with the ID add first name. So the hash means ID in this case. And then jQuery gets this HTML element, and we want to get the value, so the content of this text field, and we get it by this function, which is called val. Alright, and this has now to be done with all the other properties. So we can copy that, and we say we want the last name. Again, we can check what's the ID. Okay, it's last name, add last name. And then we also have the hero name. And if you don't know what the property actually is called, we can also go to the superhero class and see here, okay, it's hero name with a capital H and capital N. And then next would be, let's have a look again, the place of birth, which would be RESTful service.js here. It's this ID, and here it's also the place of birth. And then the last property, which would be, no, wrong file, the combat points. And here it's just called combat. Okay, now these are all the properties. Of course, we can remove the comma here. And now we have our object that has to be sent to the web service. Okay, great. Now the next thing is the AJAX call. Again, we say $, then AJAX. So far the function. And then, of course, the objects for the argument. Again, we need an URL, and this time it's service superhero service svc, and then add hero. Then we have the type again. In this case, it's post, so pay attention here. The next is the data type, same as before, JSON, since we expect a JSON from the server. And now comes something new. We have to enter the content type. The content type is the type of data we are sending to the service. Since we also want to send a JSON object, we have to enter application JSON, like that. Okay, and now the actual data, the object we send to the service. This will be our new hero object, but the server expects a JSON string, so we have to stringify the new hero object first. This can be done with the JSON stringify method, and then we pass the new hero argument into this method. So again, we just use JSON stringify, already suggested here. Again, this makes a string out of the JSON object, and here we put our new hero. Alright. And finally, again, what happens in the success case? We enter a new function, and if the user adds a new hero, we want to go back to the overview, so we call the method show overview, which is already implemented in the app.js. Okay, great. Now let's save and also build everything. And now we open Chrome again, reload the page, maybe also hard reload it. We go to ads, and now we can already enter a new hero. One thing I want to change is first I want to switch the filter to XHR again so we can see the actual call, and I remove everything from the list here. So let's say we want to add Thor. I think Thor is named also Thor with the first name. Odinson is the last name. Hero name is just Thor. I think this is something like Asgard or something. And let's say he has 85 combat points. And now we just click add. And this was fast, it already worked, because down here we can see Thor now in our list. Okay, now the great thing is, of course, in the console we see the whole call. In the headers tab we see the actual request URL, the add hero. It was a post method this time. Everything was okay. And now also new is the request payload. Here you can see the JSON object you have sent to the service. As you can see, the combat points, first name, and so on. This is the parsed object, and the actual source we have sent to the service, that's why we need to stringify the JSON, is this thing here. And then the response is just the plain hero object, and in the preview this is again parsed, and in the show overview method in the app.js the get all heroes call is also executed, and here you can also say that Thor comes back with the whole list of superheroes. Great, so everything works just fine, and now it's time to update the data of a superhero. Now, if you made it this far, you're definitely ready for the complete REST WCF Service for Web Applications hands-on course on Udemy. You have what it takes to build a RESTful WCF service from the ground up completely by yourself. In the next sections of this course, we will complete the CRUD operations with an update and delete, and we will also implement more than just CRUD, like searching for a hero, order the hero list, let the heroes fight against each other, and more. As a thank you and a reward for completing the course this far, I want to give you a pretty sweet discount. Make sure to use the link in the video description below. I'm looking forward to seeing you again in the course.